The second example with our tension problems is dealing with carrying a parrot cage. So this one isn't as bad. This one, the parrot cage weighs 215 pounds. We've got one at 62.45 degrees, one tension at 34.42 degrees to the horizontal. What is the tension on each of the ropes? So same setup we had before, and I'm going to go through this one a little bit more quickly because you've now seen the process. But here I know this is to the horizontal. We'll call this one T1 and this one T2. And once again, with these tensions, I can break up these tension vectors into the horizontal and vertical components. So I'll do that over here. So my horizontal component for T1 is going to be 31.42 with respect to cosine, because I want to use the adjacent side. So if I'm labeling out this side of the triangle, I know 31.42 degrees. I know the hypotenuse. I want the adjacent. So this is going to be T1 times the cosine of 31.42. My vertical then is T1 times the sine of 31.42. If I do the same thought process with my second tension, the x component is going to be T2 times the cosine of 62.45. Here, the vertical component is going to be T2 times the sine of 62.45. And once again, that's because I'm given this angle in here, 62.45. The opposite and hypotenuse, opposite refers to sine. The adjacent refers to cosine. So once again, this parrot cage isn't moving horizontally. So if I were to set up my horizontal pieces, T1 cosine of 31.42 has to equal the tension in the horizontal direction of the other, because the net movement horizontally is 0. So if I put this all on one side, that's going to equal 0. So there's my horizontal component. The vertical component then is working with gravity. So T1 sine of 31.42 plus the y component here, T2 sine of 62.45, is equal to the total weight pushing downward, 215. So my system of equations that I get here, if I wanted to, I could use elimination or substitution, but it's easier just to use your row reduction on the calculator. Cosine of 31.42 minus the cosine of 62.45 is equal to 0. And then the other one, the sine of 31.42, the sine of 62.45 is equal to 215. So once again, we'll head to our calculator. I still have my stuff from the last problem there. We'll just overwrite that. Cosine of 31.42 minus cosine 62.45 and 0. Sine of 31.42, sine of 62.45, and then 215. And I'll bring up my row reduction again. And I can see my matrix is going to be 1, 0, 99.670 if I round to 3 decimal places, and then 183.894. Once again, T1 is the first one, since this is 1 T1 and 0 T2s. So T1 is 99.670. T2 is 183.894. And once again, if I look at my picture up here, the T2 is tied with the larger angle measurement, which means there's more in the vertical component for this vector. So it makes sense that my T2 is going to have the larger tension.